Welcome all. I'm planning to do some sessions on YouTube wherein this will be useful for GATE, engineering services, and civil services examination, and ISRO also. I know that this series is very important, and I'm taking some quality questions. Quality means quality questions. So this video is on thermal stresses. Actually, I have selected around 22 questions. So whatever is possible in this session, I'll do. Remaining, I'll try to close in the next session. Chalo. So thermal stresses, I'll try my level best to include all types of questions. Take this first question. A circular steel rod AB. There is a steel rod AB and its length is 1100 mm and the diameter is 15 mm. This is the steel rod. Okay. And has a bronze sleeve over of outer diameter 22. This is the steel rod. This is the steel rod. This is complete steel rod. And the length of the steel rod is 1100 mm, and over steel rod there is a bronze sleeve. The outer diameter of the bronze sleeve is 21 mm and the length is 400, and it is shrunk onto SHR. It is not shrunk, and it is shrunk onto it so that two parts are securely bounded as shown in the figure. Now it is becoming a composite section. A bronze of 400 mm length is shrunk on a 15 mm diameter steel rod. Okay. Now, so that these two parts are securely bonded as shown in the figure. The total elongation of steel bar due to the temperature rise of 350 degrees centigrade is, and different properties are given. Must question hai sir. There is a steel rod of 1100 mm length and the diameter of steel rod is 15 mm, and over steel rod a bronze sleeve is shrunk. Therefore, the diameter of the outer diameter of the bronze is 21 and the inner is 15. Same, it is shrunk on the steel bar. Okay. Now it is heated to how much, sir? 350 degrees centigrade. Okay. Now he is asking what is the total elongation of steel. What is the total elongation of steel? Let's do this now. The free expansion is L alpha delta T. That is the free expansion. ठीक है, sir. And I know the total length of the steel is known, alpha of steel is known, and the temperature difference is 350, that is known. But there is a small problem. So let us take, the stresses are developed in this portion only, not in this portion. Okay. So let's take this portion, the composite section. So the length is 400 and let me show you the composite portion. This is the steel and over steel, and this diameter is 15 mm, and over steel, chalo ye steel rod hai, okay, and over this steel there is a bronze. Okay, there is a bronze. This is bronze and the length is given as 400 mm. ठीक है, sirs. Okay, and this outer diameter is also given, that is 21 mm. The outer one is bronze and the inner one is steel. ठीक है, sir ji. Now, what will happen? Let's see. So, when you are heating this, the temperature difference is given as 350 degrees centigrade. Okay, when you are heating this, what will happen? Let us say it is a composite section. Yes, it is a composite section. Outer one is bronze and the inner one is steel. Very good. So, hope you understood this. Now, let me erase. You have understood this properly. So, there is no problem. Let's see properties said. And the alpha of steel is 12 into 10 power minus 6 and bronze is 20 into 10 power minus 6. So, alpha steel is 12 into 10 power minus 6 per degree centigrade and alpha of bronze is 20 into 10 power minus 6. Okay. And the other properties are E of steel is 210, E of bronze is 110. E of steel is 210. It is given in gigapascal. I'll convert in megapascal. So similarly, E of bronze is also given. It is given as 110 gigapascal. I convert in megapascal. These are the properties given. No problem at all. Right. Now, what will happen? Let us see. As alpha of bronze is more, if you see the free expansion of bronze, if you see, it will be something like this. This is the free expansion of bronze. And you know, if you see the free expansion of steel, it will be definitely something like this. Because L alpha delta T is the free expansion. The length of the composite section is same. And it is heated to the same temperature difference. So alpha of bronze is more. Therefore, it will expand more. But it is a composite section. It has to move together. It has to move together. It cannot expand independently. So finally, what happens, you know, there will be a compressive force developed in the bronze. The total bronze may, let me write it as PB. Please note down that it is total force in the bronze. And due to that, what will happen? It will reach some position. Similarly, the steel will be subjected to tensile force. So let me write this as PS so that this is the final position of both. Now let us write the compatibility equation. So what will be the compatibility equation, sir? If I write the compatibility equation, it will be like this. L alpha delta T for bronze, this is the free expansion, minus, yes, P L by A E. Because of this large expansion, it will be subjected to compression. So the net final position of the bronze is total free expansion of L alpha delta T minus there is a compressive force of PBL. As the lengths of both are same, I am not writing LB or LS. The length is same by PL by AE. That is the actual compression. Now this is the final position of bronze and also the initial. Let's see the final position of steel. Steel is L alpha delta T is the free expansion of steel, okay, plus there is a tensile load that is PSL by AA. Excellent, sirs. This is also over, so no problem at all. Now, this two, because finally both reach the same position, this is equal. Now, understand carefully. So, we'll do one thing. L, we can remove. L can be removed. So, therefore, and one more thing, as there is no external load, the total compressive force should be equal to total tensile force. This can also be written as there is no external load, therefore the total compressive force should be equal to total tensile load. Let it be equal to some P. P is the force either in bronze or in steel. ठीक है सर. तो कुछ ऐसे करेंगे सर. अल्फा ब्रॉन्ज ये इधर लाना. So minus alpha steel into delta T. I repeat, alpha delta T, I brought this to this side, is equal to, whether it is PB, you take this to that side, whether it is PB or PS, it is same. So P or PS take common, it will be 1 by EB AB plus 1 by ES. Let me repeat, sirs. I have taken alpha to this side. So alpha B minus alpha S delta T is same. I have taken this to that side. So PS or PB both is same. So take common P. 1 by ES plus 1 by EB. This is the one final equation. Now, क्या करेंगे? Let me erase because I don't have space. So I will take this. ठीक है, sirs. Now, let us apply this. Alpha of bronze is 20 and alpha of steel is 12. So both have a power of 10 power minus 6. So ये common लिए sir, हम common लिए. And delta T is 350. That should be equal to P. Okay, I'll write here, sir. I'll write here P into 1 by EBAB. What is EB? 110 into 10 power 3, that is EB, into AB. What is the area of bronze? Bronze sleeve, the outer diameter is 21, inner diameter is 15. So therefore, pi by 4, that 4 I'll take to the top, into 21 square minus 15 square. Excellent, sirs. So, but you should be very careful with units. So I am taking this E in megapascal. What is megapascal? Newton per mm square. Megapascal is Newton per mm square. This is also mm square. So mm square gets cancelled. This will be Newton. This will be in Newton. So this is also Newton. Newton cut gap. And you know this alpha has a unit of 1 by centigrade or 1 by Kelvin. This is also 1 by Kelvin. So matching. So no problem at all. So therefore now plus देखो यहाँ पे plus 1 by AS. What is AS? 1 by AS ES. So pi by 4. The steel rod diameter is 15 into ES is 210 into 10 power 3. So if you find this value, if you calculate this value, I think you are getting. I have made calculation. So without wasting time, directly I write the value. So this value is, let me check sir. एक बार मैं check कर लेता हूँ. The value is एक second. तो ये कितना आ रहा है? 1 into 10 power 4 110 correct, so 4 by 15 square correct. So I will get the value of P as 34768 correct, 768.3, so many Newton. This is the value sirs. Now what is he asking? The total expansion of steel. मेरे प्यारे दोस्तों, in steel there is a tensile load of this in 400 meter length. In steel there is a tensile because that portion, एक बार देख लेना सर, only एक बार, let me erase all this, only this portion of 400 is subjected to a because of the composite section, and the apart from this load of P in steel, there is a free expansion also. So there is a tensile load due to this composite section. Because of that, it is expanding. Suppose there is no sleeve. So if you are heating this steel over to 350, there is complete steel hai. ध्यान से सुनो. Let us say there is only steel of 1100 mm length, and it is subjected to and it is heated to 300 to a difference of 350 degrees centigrade. So it will be L alpha delta T. Plus apart from this, this portion is subjected to tensile load. So L alpha delta T plus because of this load, it expands. So the total expansion of steel will be L alpha delta T plus P. L is that composite is 400 by AE. This is the expansion due to this. In the composite section, there is a load P. This is the free expansion. So please note on that the length of the steel is 1100. Okay. Alpha of steel is 12 into 10 power minus 6 and delta T is 350. Correct. Plus P. What is P, sir? This one. 34768.3 and L. I'm taking everything in mm so that L is in mm, you'll get in mm. Why are you not writing this as 1100? Because the composite section is of 400 only. So if there is no composite section, if you heat it freely, so it will expand freely by L alpha delta T. Plus there is, due to composite section, as bronze is shrunk on the steel, steel will be subjected to additional tensile for 400. So because of that additional axial load of this, it will be PL by AE. And A is, dekho, this load by A, it is pi by 4. Steel is 15 mm and E is 210 into 10 power 3. So therefore, now let us find out this value. Let me check this value, sir. एक second. Correct. Plus ये कितना आ रहा है सर? 12 into 350. I think the total, this is coming out to be 4.62 and that is 0.4 something. So you are getting the answer as 4.99 mm. This is one of the good questions. So hope you understood. Let me check the option if there is an option. Yes, 4.99 is the correct option. ठीक है sir. Let's go to the next question. Second question. Let's go to the next question. ठीक है sir जी. A prismatic bar with a length of 1 meter and cross-sectional area 1200 is supported at the ends. The bar is subjected to a temperature increase of delta T is 25. The complete state of stress acting on an inclined section section RS that is cut through a bar at an angle of 45 degrees. See the figure. Actually, this is the bar, sir. This is a good question. This is a bar. The diameter is given. and it is supported between rigid supports. Now it is subjected to a temperature difference of 25 degrees centigrade. The length is given as 1 meter and delta T is given, area is given. Now, what is he asking? He is asking the state of stress on this plane RS, which is at 45 degree with this 45 degree. Okay, so he has given some state of stresses. So let us do this problem. Don't worry. At 45 degree in is same. With respect to this, it is 45 degree in anti-clockwise direction. Anti-clockwise direction मतलब ये plane पे पूछा सर, A plane पे. On this plane he is asking. चलो, I'll do it. Don't worry. Let me do it. So एक बार data देख लेंगे सर. First, let us find out the stress. This length is given as 1000 mm because 1 meter is given, so 1000 mm, and the area is also given 12. Okay, E is given and alpha is also given, no problem at all. एक बार देखना sir. The free expansion is given by L alpha delta T. The length is 1000 mm. Alpha is given. What is alpha, sir? So 12 into 10 power minus 6. And delta T is given. What is delta T? It is 25. So you get the value of kitna aa raha hai, sir? Ye? Let me check. How much is this? 1000 into 12 into. Okay. I think you are getting this as 0.3 mm if I am not wrong. ठीक है सर, एक बार चेक करता हूं सर. 1000 into 12 into 10 power minus 6 into 25. Yes. Now, but you know very well, are you allowing any expansion? No. It tries to expand, but the wall is not allowing. So there is a compressive force developed in this. Let the load be P. Let the load be P. So therefore, now 0.3 is the free expansion, but you are not allowing it to expand. So therefore, whatever is the compression, this is the free expansion, this is the free expansion. So compression should also be the same. Why? Because you are not allowing any free expansion. So therefore, so whatever the compressive force is developed, it should produce this much compression so that net will be zero. So because there is, this is the rigid wall, this is the rigid wall. So therefore, this 0.3 should be equal to PL by AE, because you are not allowing any expansion. So therefore, the actual force will be PL by AE. So because of expansion and because of compression, net result should be zero. So tension, free expansion should be equal to compression due to this actual force, generated. Okay. So as I have taken in mm, एक बार हम P को calculate, or let me do this. P 0.3 is equal to, what is P by A? I will write P by A as sigma. So on this area, the force is acting. So P by A is sigma into L by E. Excellent, sirs. So therefore, 0.3 will be equal to sigma. What is sigma, sir? I don't know. And length. What is the length, sir? 1000 mm. 1000 mm. 1000 mm. PL. Dekho, this is sigma. L is 1000 mm. As this is an mm, this will also be an mm. E. What is E? 200. Let me convert giga to megapascal. Giga to megapascal. So ye hoga, sir. So I think you are getting sigma as 60 megapascal. So therefore, there is a compressive stress of 60 on this plane. There is a compressive stress. Now let us try to understand this. There is a bar. So if I draw the show the element, it is subjected to a compressive stress of 60 megapascal. So it is subjected. एक बार देख लेना. Just see, it is subjected to a compressor and it is free in this direction. So therefore, now this is the state of stress. So let me write very clearly. So sigma x is equal to minus 60. There is no sigma y. So therefore, sigma y is equal to 0. There is no shear stress. Therefore, tau xy is equal to 0. There is only compressive stress. Now let us try to draw the Mohr circle. The center of the Mohr circle is sigma x plus sigma y by 2 comma 0. So the center of Mohr circle is sigma x is minus 60, sigma y is 0. Minus 60 plus 0 is minus 60 by 2 is minus 30 comma 0. And let us find out the radius of Mohr circle, and that is given by sigma x minus sigma y by 2 whole square plus tau xy whole square. ठीक है, sir. So Mohr circle radius is given by under root of sigma x. What is sigma x, sir? Minus 60, and sigma y is 0 by 2 ka whole square, and there is no tau x square, it is 0. So therefore the radius will be equal to kitna aa raha hai sir? So this is 30 square is 30 only. So therefore if you draw more circle, it will be like this. There is a normal stress and there is a shear stress. And where is the center? Center is minus 30, 0. So I think this is minus 30. Chalo isko minus 30 le lenge, 0. And the radius is also 30. So therefore the circle will be something like this. This is the more circle. ठीक है sir, no problem at all. And you know, if this is 30, एक second, ये थोड़ा odd दिख रहा है. Okay, this is 30. So this is 30, this is 30, and this is minus 60. You know very well. Now, this is the center. Okay, sir. Now, let us take any reference plane. So reference plane, let me take this. अगर मैं इसको reference plane ले रहा हूं, so the same reference plane, let us say this plane को A ले लेंगे sir, A. Let me show this plane. On this plane, there is a compressive stress of 60 and there is no shear stress. तो वो प्लेन कौन सा हो सकता है? देखो देखो, here what are the coordinates of this? What are the coordinates? The compressive is 60, that is minus, and there is no shear. Shear is vertical, shear is vertical. तो इसमें shear कोई नहीं है. So this is showing this plane. ये वाला, because the compressive is 60, yes it is 60, and इस पे कोई vertical distance नहीं है, तो shear 0. तो ये plane होगा आपका. This is my plane A बोलूंगा सर इसको. And he is asking at 45 डिग्री, इसको 45 डिग्री, इसको 45 डिग्री, इस प्लेन को 45 डिग्री at 45 डिग्री एंटी क्लॉकवाइज. सो अगर ये 45 है, on this plane he is asking the state of stress at 45 degree anti clockwise, anti clockwise, anti clockwise. So on in the actual it is 45, on more circle it will be twice. तो एंटी क्लॉकवाइज ट्वाइस आ जाना. तो ट्वाइस का मतलब क्या है? अगर ये 45 है, यहां पे 90 आना चाहिए सर. आई हैव टू कम 90 90 90. सो दिस इज द प्लेन, मतलब हमें ये चाहिए सर. आई वांट द स्ट्रेस. तो व्हाट इज सिग्मा सर? इट इज minus 30. सो ऑन दिस प्लेन if you are saying it is minus 30, देखो this sigma is minus 30. चलो minus 30, very good sir. And at the same time, if you see the shear stress here, the normal stress is minus 30 and the shear is also minus 30. On more circle, whenever the shear is minus, it means it is anti-clockwise. So on this plane, anti-clockwise का मतलब क्या है? I think ये ऊपर ये नीचे, the magnitude is 30 only. Yes, 30. So अगर ये एंटी क्लॉकवाइज आ रहा है, this should be clockwise. Very good sir. Now I want, देखो on this plane I want, इस प्लेन पे चाहिए सर, इस प्लेन पे चाहिए, on this plane. So very simple. तो these two planes are, this plane and this plane are at 90 degree, 90 degree. तो यहाँ पे क्या होना चाहिए? 180. So अगर ये वाला है, so on this if it is 30, on this if it is 30 and this will be 180, मतलब actually इधर 90. तो कितना आ रहा है सर? यहाँ पे भी same आ रहा है सर, same. So if you see it is 30 only, but on the left side. So therefore it is also 30, it is also 30. So there is a compression of 30. So if you are drawing the element, it will be something like this, my dear students. If you are showing the element, it will be something like this. 30. This is also 30. अभी तो देखिए. And there is anti-clockwise और यहाँ पे clockwise है सर. तो इस प्लेन पे क्लॉकवाइज आ रहा है, मतलब दिस टो विल बी पॉजिटिव, दिस टो एंड दिस विल बी minus 30. देखो एक बार, if you just see this tau is positive, 30 is positive and this tau is negative. So इस प्लेन पे आ रहा है, मतलब इस प्लेन पे it is minus means anti-clockwise. Yes, anti-clockwise. इस प्लेन पे it is plus 30, origin से plus 30. So clockwise, clockwise. ये shear 30, 30. And you know, from normal stress is minus 30. So compressive is minus 30. So this is the state of stress. And if you see, where is it? Where is it? Let me check. And these are all new variety questions. So be careful, my dear students. Yes, sir. क्या आ रहा है सर? Compressive. ये नीचे नहीं था. No, it is not clockwise. There is no tensile. D is also wrong. Compressive. ये क्या आ रहा है सर? एक ही दिया, क्या दिया है? Both figures are looking same ना? Both figures are looking same. ये टेंजाइल आ रहा है सर, ये टेंजाइल. गलत. दिस इज टेंजाइल इज नॉट करेक्ट. दिस इज करेक्ट आंसर. दिस करेक्ट. एक बार चेक कर लेना. यस सर. वेरी गुड. लेट मी चेक. Yes, B is the right answer, sir. B is the right answer. So B is the right answer. This is a very good question. बहुत बढ़िया. Now let us take this question. A very good question. Read the question. The figure is also given. Yeah, the figure is also given. Look at a plastic bar ACB. Let me check. ACB. This is a plastic bar, but of different cross section. Okay. Huh. Is held between ये नहीं रे बाबा, not this, ये वाला. A plastic bar ACB having different solid cross sections is held between rigid supports and a spring is attached as shown in the figure. The diameters in the left and right part are given. Left में 50, right part. Okay. The corresponding lengths are also given. The modulus of elasticity is also given. ठीक है sir. And the coefficient of thermal expansion is given. Only ACB is subjected to uniform temperature. What does it mean? So we are heating only this. That means the spring is not subjected to any heating. Only this portion is heated to uniform heating. ठीक है sir. Now uniform heating. Then the uniform heating and is subjected to uniform increase of delta T is increase of 30. There is an increase of 30 degree. Which of the following MSQ has sir? Which of the following statements is or are correct? देखो, compressive force in the bar, the maximum compressive stress in the bar, the minimum compressive stress. Okay. So आपको total load calculate करना है. So what is the load acting on this and then the maximum compressive stress. मुझे पता है sir, the maximum compressive stress will be in this because area is less. Minimum will be in this. He is asking all. चलो देखते हैं sir. How do we do this? Must question है sir. Let me do this. देखो एक बार. First, always remember in thermal stresses, the most important part is compatibility equation. Let me do that. देखो, एक काम करते हैं sir. E is given as 6 and alpha is 100 into 10 power minus 6. E is given as, let me note down the data. एक बार मैं data, let me note down sir. यही है, देखो. So, ACB. And this length is 225, this length is 300. Okay. And और क्या दिया है sir? The diameter is also given 50 this. Okay. E कितना दिया sir? 6 into 10 power 3 mega. Actually, it was given in gigapascal. So I converted into megapascal. Megapascal is Newton per m square. And alpha is given as 100 into 10 की power minus 6. That is also correct. Okay. Now delta T is given as 30 degrees. Okay. अब देखते हैं sir. Very simple. कुछ नहीं करना. What I do is only this portion is heated. So what will happen? It will expand freely. So let us calculate the free expansion of this portion, the free expansion of this portion. ठीक है sir. Now L alpha delta T. Let us calculate free expansion. So what is the free expansion? For this it will be L AC. L alpha delta T for AC portion plus there is a free expansion for this, there is a free expansion. L alpha delta T for the portion BC. ठीक है sir, कोई problem नहीं. Now understand. So I think material is same, alpha is same and the temperature difference through which both are heated is also same. So I can do this like alpha delta T, let us take it out. So length of AC plus length of BC. Okay, I have taken alpha delta T. Already alpha is known. It is 100 into 10 power minus 6 into alpha into delta T. What is delta T? It is 30 into delta T is 30 into length of AC plus length of BC. AC is 225 and BC is 300. So when you add 300 plus 225, I think it is 525. ठीक है sir? Directly I am writing 525. Wait, as this is in mm, or complete answer will be in mm. So what is the free expansion? So I think I have already calculated. एक बार मैं check कर लेता हूँ. Let me write this as total free expansion. So that will be equal to, let me check. This is question number. एक second. हाँ, ये आ रहा है sir free expansion. एक second. 300. एक second. 300. 520. 1.100 into 10 power minus 6. Correct. Into 30. Yes, 1.575 mm is the free expansion. Now let me write. So are you allowing it to expand? No. Dekho, when it tries to expand, it is not expanding. So there will be a definite, when it is trying to expand, it will not expand. there will be compression. मेरे प्यारे दोस्तों, this and this force should be same. Why? There is no external force. When there is no external force, the sum of the rightward force should be equal to sum of the downward force, leftward force. Rightward should be equal to leftward. So I am writing R1 R2 जो भी है या P1 P2. So I will write. So let me write this as R1 and this is R2. But there is no other external force. So R1 R2 let it be equal to some P. P is the compressive load. So I am writing. So when it tries to expand, the wall will oppose, there is compression. It tries to expand, wall will oppose. So मान लो ये R1 है वो R2 है. But you know there is no other external force. So therefore it is in equilibrium. So this force should be equal to this force. So R1 is equal to R2. Let it be equal to P. ठीक है सर. So what will be the force in the spring? P. What will be the force in this P? What will be the force in this P? But stresses are different in this. What is the reason? The areas are different. So what is the compatibility equation? Already you have calculated free expansion 1 point, but are you allowing free expansion? The answer is no. So whatever it is trying to expand, that is resisted by this compression and spring compression. So total compression of spring, because when it is expanding, the spring is compressed. The total expansion, the free expansion is compensated by, because the distance between these two supports is constant. When it is constant, total expansion should be equal to total compression, so that net will be 0. So there is compression of spring. Because of the load P, there is compression in this member. Because of load P, there is compression. Compression of this plus compression of this plus compression of this, total compression should be equal to the total expansion. So let me write the ये value लिखेंगे sir 1.575 याद रख लेना. This is the free expansion 1.575. So let me erase this so that in the same figure I can solve happily. चलिए ठीक है सर. देखो एक बार. हाँ, what is the compression of spring? The load is P. You know, the spring index is given by P by delta. So compression of this will be equal to P by K. So P by K. So the load in the spring is P by K. Okay. Plus, because of this load, it is compressed. So it will be P, length is 50 by area. What is the area of this? Pi by 4 d square. What is that d square? Oh, sorry. I'm really sorry. PL by AE na. 1 second, please. The load in this is P and the length of this is 225 at the area. PL by area. Pi by 4 d square. What is d square? 50 square. PL by A. E. What is the Young's modulus? It is 6 into 10 power 3. ठीक है. Plus इसमें P L, what is the length of this? 300 by area. Pi by 4 d square is 75 square into E. What is E? 6 into 10 power 3. So therefore this is the total compression and already K is given. Somewhere K is given. एक बार देख लेना. The value of K is, where is K given? Let me check, sir. 3. It is given as 50 mega Newton per meter. 50 mega Newton per meter. So, okay. But you should be careful with unit. एक बार देखना K. एक बार देखो PL by AE. Let me keep P in Newton. Length in mm. Area is mm square. And this is E is megapascal, means Newton per mm square. Area mm square गया, Newton गया. This is in mm. So ये total value mm में आ रहा है sir. This value is in mm. So this should also be in mm. देखो K is given as 50 mega, कितना दिया? 50 mega Newton per meter. तो K is 50, mega is 10 power 6 Newton per mm. Per meter. तो आई विल राइट दिस मीटर. एक बार देखना 50 मेगा न्यूटन पर मीटर. तो मैं mm में कन्वर्ट करता हूं. आई विल कन्वर्ट. सो बिकॉज दिस कंप्लीट वैल्यू इज इन mm. तो इसको हम न्यूटन में रखेंगे. इसको अगर न्यूटन पर mm में रखेंगे तो दिस विल बी इन mm. ऑल आर इन mm. सो देयरफॉर आई एम कन्वर्टिंग दिस सर. इसको मैं कन्वर्ट कर रहा हूं. देखो तो 50 मेगा न्यूटन पर मीटर. मीटर कैन बी रिटन एज 1000 mm. Meter. So this is gone. So it will be pi into 10 power 4 or 50 into 10 power 3. So k can be written as 5 into 10 की power 4 or 50 into 10 power 3, whatever it may be. So units are matching. So it is 50 into 10 power 3. This is the total compression because compression of the spring, compression of this rod, compression of the total compression should be equal to total expansion. Already total expansion is 1.575. These are all quality questions. Everything is known except P. Calculate karo. And I have already calculated. तो कितना आ रहा है सर? Let me check. Hmm. एक बार देखते हैं सर. Very good. Very good. 10 power 3. Correct. So P is turning out to be 31240. 31240. 31240 Newton, or this can be written as 31.24 kilonewton. That is the compressive load. Option देखना एक बार. Option देखना. The compressive force is 51.7. No, the compressive force is 31.2. B is correct. Let us calculate the maximum and देखो एक बार. अब बहुत सरल हो गया सर. Now already we have calculated P. So what will be the stress in this member? So let me erase this, sir. आराम से. This is 1.575 ना. देखो, what will be the compressive stress in this? So I can write this as a minimum compressive stress. Why? The load is same, the area is more, the stress will be less. The load is same, the area is less, stress will be. This will have minimum. Sigma minimum is equal to what is P, sir? P is 31240 by area. That is pi by 4 d square 75 square. So many megapascal. And if you want sigma maximum, here it will be sigma maximum in this. So sigma maximum will be equal to load P. P is 31240 by area. Pi by 4, your diameter is 50 square. So this you are getting, kitna aa raha hai, sir? I think you are getting this as 15.9, and this one minimum is 7.07. So many megapascal. 15.9. The maximum is the maximum compressive stress is 7.07. No, no. The maximum compressive stress is 15.9. Correct. And the this is not maximum. This is minimum. So minimum compressive stress is 7.08. Yes, minimum is 7.07 is correct, and the maximum is 15.9, and the load is this. So B, C, D are correct. यहाँ पे correction करना sir. यहाँ पे minimum करना. Minimum compressive stress is 7.07. This is also a very good question. बहुत बढ़िया. Next. Take this question. Now let's go to some non-uniform heating. Till now we have seen uniform heating. ये नॉन यूनिफॉर्म हीटिंग तो बहुत ही सिंपल रहता है सर. वेरी सिंपल. सिंपल इंटीग्रेशन. उसमें कुछ है ही नहीं. उसमें कोई हाइप क्रिएट करने की जरूरी भी नहीं है. सिंपल इंटीग्रेशन. देखो कितना इजी वे में आई विल सॉल्व दिस. यू जस्ट सी. कम ऑन रीड द क्वेश्चन. फिगर दिया क्या सर? हाँ दिया सर. फिगर इज गिवन. देखो ए बार ए बी ठीक है, of length L is held between rigid supports. This is one support, this rigid supports means the distance cannot move. ठीक है. And heated non-uniformly. डरो मत सर. I'll tell you what is the physical meaning of non-uniformly. इतना आसान क्वेश्चन है सर. ये देख के आप आई डोंट नो क्यों डरते हैं. इसको कितना हाइप क्यों क्रिएट करने की जरूरी नहीं है. कोई जरूरी नहीं. इतना सरल सिंपल क्वेश्चन है. देखो चुटकी में कर लेंगे हम. In a manner that the temperature rise at a distance x is given by the expression. The temperature rise is given as this. Okay, where delta B is. I'll explain everything first. Let me read the question. Where delta TB is the increase of temperature at NB, and the bar is shown. E is the modulus of elasticity. Alpha is the quotient of thermal expansion. The expression for compressive stress in the bar is. ठीक हो. Delta T is delta TB x cube by L cube. Delta T is delta TB x cube by L cube. Let me check. Delta TB, delta T is delta TB x cube by. अब देखो सर, लेट मी डू दिस. मीनिंग क्या है सर? टिल नाउ whatever, suppose मेरे पास एक बार है सर, suppose I have a member, this member. So when we are heating, complete is, देखो, heated to the same uniform temperature. मतलब whatever the difference is there are everywhere, whatever originally it is at some temperature, let us say 50 degrees, originally say it is at some 20 degrees centigrade. Now I am heating. When I'm heating, let us say the final temperature is 50, originally is 20. So what is the difference? 30. So everywhere the difference of temperature, uniform heating, 30, 30, 30. But अब क्या बोल रहा है, ध्यान से सुनो. You are heating. So here initially whatever the temperature is there, finally is also same. Because the difference, this is given as difference temperature. Difference in temperature is 0. And if you take this section, this is the difference of temperature. If you take this section, this is the temperature difference. If you take this section, this is the temperature difference. It is a cubic. So डरो मत सर, कुछ भी नहीं है सर इसमें. There is nothing in this. I'll explain. So the temperature difference is not same everywhere. So whenever it is changing along the length, maths is ready sir. कैसा ready? मैं बताता हूं. देखो, let us take, ये तो डेल्टा टी है. So I will do what I do is, देखो सर, यहां पे डेल्टा टी इतना है, यहां पे डेल्टा टी हल्का सा ज्यादा है, बिकॉज इट इज अ फंक्शन ऑफ एक्स. इफ आई टेक वेरी स्मॉल लेंथ dx, if I take very small length dx, what will be the difference? Almost same. अरे यार, it is delta t is a function of x. When x is varying, delta t is varying. When x is varying in a very small manner, delta t is also varying in very small manner. So if I assume in a small length dx, in the small length dx, the temperature difference is almost constant. तो मैं क्या कर रहा हूं, यूनिफॉर्म की तरह ट्रीट कर रहा हूं स्मॉल लेंथ में, बिकॉज द डिफरेंस इज वेरी स्मॉल. तो क्या होगा सर? द फ्री एक्सपेंशन इज गिवन बाय L alpha delta t. In all previous questions, this delta t was same throughout the length, but now delta t is not same throughout the length. So what I do is, let us find out the free expansion in a small length. मतलब अगर लेंथ dx है, उस लेंथ dx को आप हीट कर रहे हैं तो कितना एक्सपेंड होगा देखेंगे. तो my L will be dx, alpha is constant, delta t. What is delta t? Delta tb x cube by L cube. This is the expansion in a small length dx. अगर small length dx को हीट कर रहे हैं, इतना एक्सपेंड होगा. But are you expanding only small length? No, you are heating completely. तो इसको इंटीग्रेट करो. So total expansion will be equal to, I'll integrate, x is varying from 0 to L. X is varying from 0 to L. That's it sir. ये आ गया तो बस खत्म. In all non-uniform heating यही करना है. इसमें कोई बड़ा rocket science नहीं है. Let us take a small length. Delta t is a function of x. If delta t is varying with x, I will take very small length dx. So the free expansion is given by L alpha delta t. If I take length as very small, it will be dx. So dx, L is dx. And why dx? Because in a small length, the temperature difference is almost same. So in a small length dx, जैसे डेल्टा टी पूरे लेंथ पे सेम था, जैसे this delta t is same in a small length dx. तो L is dx, alpha delta t is this. Now this is giving me expansion in a small length dx. If you want the total, integrate from x is 0 to L. That's it sir. So therefore the total free expansion is given by alpha is constant, delta tb is constant, L cube is constant, alpha is constant, delta tb is constant, L cube is constant. Now integration of x cube dx. x cube dx क्या होता है? x power 4 by 4. Integration of x cube dx. Therefore x cube dx is x power 4 by 4 and it is 0 to L. So therefore delta L will be equal to alpha delta tb by 4. ठीक है सर, यहां पे देखो upper limit, lower limit is 0, leave it, upper limit L power 4. तो L power 4 by L cube. This is L power 4 by L cube will be L. So this is the free expansion. The free expansion is given by, यहां पे जगह नहीं है सर, the free expansion is given by L alpha delta TB. Let me repeat. L alpha delta TB by 4. This is the free expansion. लेकिन what is he asking in the question, sir? What is he asking? क्या पूछा है सर? कंप्रेसिव स्ट्रेस पूछा है, तो व्हाट इज दैट? व्हेन यू आर हीटिंग, you will it expand? No, because there is a rigid, these are rigid supports, so load is generated, sorry, the stress is generated in this, so therefore it tries to expand but the wall is preventing. So what will be the, so the total expansion due to the thermal due to heating should be equal to the compression due to this axial load, because there is no net change, these are rigid walls. तो क्या होगा सर? PL by AE. Excellent, sir. This is because of this there is actual compression, but you know there is no change in the distance, so net expansion should be equal to net compression. So likho, so this is the net expansion. So L alpha delta TB by 4 is the net expansion, that should be equal to net compression, so it will be PL by AE. And you know very well what is P by A. P by A is the compressive stress sigma. So therefore मेरे प्यारे मित्रों, क्या बोला मैं आपको? प्यारे मित्रों बोला. So if you write, ये वाला ले लो, तो इसको मैं हटा दूंगा सर. Let me erase this. तो I get this L is gone. So alpha delta TB by 4 is equal to this is sigma by E. So if you want this sigma, my dear students, अगर सिग्मा चाहिए, alpha delta TB E by 4, alpha delta TB E by 4. So therefore the answer is alpha delta TB E by 4. Option C is correct. Alpha delta TB E by 4. Very good, sirs. Very good. Wonderful students. Okay, that's it. For all non-uniform heating यही करना है सर. ठीक है. Take the next question. Take this. Again, it is almost similar, लेकिन थोड़ा कॉम्प्लिकेट कर देंगे इसको. Just will complicate. स्प्रिंग लगा देंगे. कुछ नहीं है सर. There is nothing here. मैं बताता हूं why there is nothing here. अब बताता हूं. Same problem, previous problem. Now instead of rigid two supports, a spring is the same question, sir. Delta T is delta TB x cube by L cube. Exactly same, but there is a spring of stiffness K. तो क्या पूछा है सर? The expression for compressive stress in the bar. That's all. कुछ नहीं है. Compressive stress in the bar. There is nothing in this. Just 2 मिनट में कंप्लीट करेंगे सर. इसको सिर्फ 2 मिनट में. इधर देखो सर. तो you know, so if I take small length dx, तो क्या होगा सर? The free expansion is L alpha delta T. So length हम dx पे ले लेंगे alpha. What is delta T? I think it is the same profile. Delta TB x cube by L cube. Delta TB x cube by L cube. Exactly. So इसको हम क्या करेंगे? Now we'll integrate this from 0 to L. It is the same one what we have done. So alpha is constant, delta TB is constant, alpha is constant, delta TB, and by L cube. And what is x cube dx? X power 4 by 4. And my limits are 0 to L. So alpha delta TB by 4 and L. ये तो सेम ही है, प्रोफाइल सेम है. दिस इज द फ्री एक्सपेंशन. दिस इज द फ्री एक्सपेंशन. So what is the free expansion, sir? The expansion is alpha delta TB by L cube आया, यहाँ पे L power 4. So this is L power 4 by L cube. So this will be L by 4. Yes, same है. Now what is the compatibility equation? This is the rigid support, this is. So when you are supplying heat, this expands. But are you expanding? Are you allowing the expansion? No. Therefore, the compressive stresses are developed. अगर ये R1 है, अगर ये R2 है, tell me the relationship between R1 and R2, because it tries to expand, but the wall is preventing. So compressive stresses. Is there any external force? Answer is no. So therefore, R1 should be equal to R2. समझो sir. R1 is equal to R2. Let me write it as P. Let me write it as P. So therefore, now the net expansion should be compensated by the compression in this, the compression in the spring. That's it. So the total compression of spring and this rod should be equal to the total expansion which you have calculated. Bas, that's it. Just 2 minute का question है sir. देखो, what is the compression? P, देखो, spring stiffness is load by K, so compression will be equal to P by K. तो ये क्या होगा? P by K इसका होगा compression plus इसका compression, because the load is P, इसमें भी load है, PL by AE. Let me repeat. PL by AE is the compression of the bar. P by K is the compression of spring. Total compression should be equal to total expansion. खत्म. इसके लिए इतना टाइम क्यों बर्बाद कर रहा है? खत्म. बाय बाय, टाटा, गुड बाय, गया. देखो क्या करेंगे इसको, बहुत सिंपल है सर. देखो alpha delta TBL by 4 is the total expansion, should be equal to compression of the spring. जो जो बार एक्सपेंड हो रहा है, देखो ड्यू टू फ्री एक्सपेंशन अगर होगा तो वो नहीं होने नहीं दे रहे, तो वॉल विल कंप्रेस. तो कंप्रेशन ड्यू टू P in the bar plus compression due to compression of the spring, total compression should be equal to total free expansion. So therefore PL by AE. Excellent sir. लेकिन what did he ask? He asked stress. देखते हैं सर क्या करेंगे. अल्फा डेल्टा TBL by 4 is equal to P को बाहर ले लेंगे तो 1 by K plus L by AE. Excellent sir. क्या हो जाएगा सर. सो नाउ आई विल राइट P will be equal to alpha delta TBL by 4 1 by K plus L by AE. Excellent sirs. But is he asking force? No. So what will be the stress in this bar? If you want stress, divide with area. This load by area. तो इस लोड को एरिया से डिवाइड करो, दोनों तरफ एरिया से डिवाइड करना. तो सिग्मा इज इक्वल टू P by A. सो देयरफॉर P by A. तो अल्फा डेल्टा TBL by एरिया, दोनों तरफ एरिया से डिवाइड करना, और 4 है यहां पे, और दैट एरिया तो अंदर ले लेना A. तो A by K plus L by E. I think it is correct. Is it correct, sir? एक सेकंड. 4 एरिया डिवाइड विथ एरिया, तो स्ट्रेस चाहिए, तो ऑलरेडी P इज नोन, P वैल्यू है, P को एरिया से डिवाइड करना, अल्फा डेल्टा P बाय A. तो A अंदर लिए A कट गया, तो ये आ रहा है सर. सो आई थिंक अब क्या करेंगे, ऑप्शंस देखते हैं एक बार. विल सी ऑप्शंस. व्हाट आर द ऑप्शंस, एक बार चेक करते हैं सर. प्यारे बंधुओं, एक सेकंड. वो क्या किया है सर, एक काम करते हैं सर जी, अल्फा डेल्टा TBL बाय 4. एक काम करते हैं देखो L by E बाहर ले लेना, L by E बाहर लिए तो 1. L by E बाहर लिए तो क्या होगा सर, इफ आई टेक L by E बाहर, इट विल बी E by L. दैट्स इट. अरे यार ये भी ना यार, इफ यू सी, सो यू टेक L by E इनसाइड, L by E, तो L by E इनसाइड है तो L by A by K. बहुत बढ़िया. तो ये L कट गया, दिस E विल गो टू द टॉप. अल्फा डेल्टा TBE by 4 times 1 plus AE by KL. तो यही तो ऑप्शन है सर, अल्फा डेल्टा TBE by 4 1 plus. यस, आई थिंक ऑप्शन सी इज करेक्ट. मेरे प्यारे बंधु, मस्त क्वेश्चन है सर. डोंट वेस्ट मच टाइम सर. आई थिंक दिस इज करेक्ट. EA by यस, यही तो आया ना. यस, अच्छा क्वेश्चन था सर, ठीक क्वेश्चन, मतलब नॉट सो मतलब टफ. सिंपल इंटीग्रेशन, वेरी गुड. ये वाला करो, हाँ ये वाला करो. डू दिस. कम ऑन. पढ़ो एक बार, रीड द क्वेश्चन. देखो, a pipe is made of a steel and is connected to the collars A and B. When the temperature is 18 degree, there is no axial load on the pipe. इस पाइप पे कोई एक्शन लोड नहीं है. The temperature of the pipe increases by 20 plus 30x. The temperature is increasing by this much. Delta T दे रखा है. Again, it is non-uniform heating. देखो एक बार, is it same everywhere? No sir. Delta T जब x बढ़ रहा है तो delta T is also increasing. बहुत अच्छा क्वेश्चन है सर. So it is again a non-uniform heating. So if you put x0 here, the temperature difference is 20. If you put x is equal to 3 meter, x is in 3 तो कितना आएगा, मतलब यहां पे टेम्परेचर आ गया. देखो एक बार, put x is equal to 3 एंड पे 3, तो 30 into 3 is 90 plus 20 is 110. So here the temperature is 20, here the temperature difference I'm talking, delta T, directly delta T is given. क्या करेंगे, अगेन इट इज सेम, कोई रॉकेट साइंस नहीं है। बट यहां पे क्या पूछा है सर, stress in the pipe पूछा है सर, बहुत बढ़िया। some fluid is flowing because maybe when the fluid is flowing definitely there will be heat transfer, because of that the temperature is changing, so it is a non uniform क्या बोलते हैं heating। तो again the logic is same। तो what is delta t given in the problem sir? this delta t is given as, देखो एक बार, delta t is given as 20 plus 30x, 20 plus 30x, क्या करेंगे सर, अगेन द लॉजिक इज सेम। द एक्सपेंशन इज L alpha delta t, this is the free expansion if the temperature is same throughout in a length L, but here देखो the temperature is not same, difference is not same throughout, तो क्या करेंगे, first I'll calculate in a small length, my L will become dx, alpha is alpha and delta t, what is delta t, L is dx, alpha is alpha, delta t is 20 plus 30x, this will give me expansion in a small length dx। if you want the total, integrate from 0 to L। यहां पे लेंथ कितना दिया सर, here the length is given as 3 meter, length is given as 3 meter, but you should be cautious here because clearly वो बोला है x is in meter, तो आपको ये आंसर आएगा, this answer will be in meter, be careful this expansion, so I'll write the total expansion करो, alpha, I think alpha value is known, what is alpha value sir, somewhere it is given, somewhere 12 into 10 power minus 6, alpha value is 12 into 10 power minus 6, इसको बाहर ले लो, इंटीग्रल 20 plus 30x into dx and x is varying from 0 to 3, ध्यान से सुनो ये मीटर में है सर, बिकॉज ऑलरेडी x इज गिवन इन मीटर, तो ये किस में आएगा सर, मीटर में आएगा, बिकॉज वी आर टेकिंग इट इन मीटर। चलो देखो 12 into 10 power minus 6, okay sir, and 20 into dx will be 20x plus 30, x dx is x square by 2 and it is varying from 0 to 3, एक second, so the total expansion is given by 12 into 10 power minus 6 into ये 20 into 3, ओके अपर लिमिट, लोअर लिमिट का कोई सिग्निफिकेंस नहीं है, 0 0 है, 20 into 3 ये 15 लिखेंगे, 15 into x square, तो इट विल बी 15 into 3 square, दिस विल बी इन मीटर। अगर मैं इसको 1000 से मल्टीप्लाई करता हूं तो mm में आएगा, लेट मी चेक सर, 9 कितना आ रहा है सर, इज दिस करेक्ट, is 2.34 कुछ आ रहा है सर, yes, so it will be 2.34 into 10 power minus 3 meter और 2.34 mm आ रहा है सर, बट व्हाट इज ही आस्किंग सर, व्हाट इज ही आस्किंग, नॉर्मल स्ट्रेस, कैसे करेंगे सर, एक्चुअली ये पाइप है तो द क्रॉस सेक्शन इज समथिंग लाइक दिस, सो द इनर डायमीटर दिया है, कुछ दिया है सर, द इनर डायमीटर इज 60, ये इनर डायमीटर इज 60 एंड द वॉल थिकनेस इज 3 mm। चलो पाइप ऐसा है सर, देखो द पाइप इज लाइक दिस, द इनर डायमीटर, डायमीटर दिया है, रेडियस दिया है, एक बार देखते हैं, इनर डायमीटर इज 60, तो कैन आई राइट रेडियस एज 30, द इनर डायमीटर इज 60 तो रेडियस इज 30, तो रेडियस इज 30 and the wall thickness, what is the wall thickness, what is the wall thickness, देखते हैं सर, wall thickness is 3 mm, wall thickness is 3 mm, so can I write the inner radius is 30 mm and the outer radius is 33 mm, yes sir, so this is the material, this is the pipe material, look at, and you know very well actually it is like this, देखो दिस द पाइप मटेरियल, यहां पे कॉलर्स है सर, यहां पे कॉलर्स है, फ्लूइड फ्लो हो रहा है एंड नॉन यूनिफॉर्म हीटिंग चल रहा है, तो विच एरिया इज रेजिस्टिंग, ओनली जो मटेरियल है, इसमें तो फ्लूइड फ्लो हो रहा है, देयर इज नो मटेरियल लेफ्ट हियर, तो इसमें तो व्हाट इज द लुक एट, एंड देयर इज यहां पे कॉलर्स है सर, देखो एक बार फिगर देखना, यू विल अंडरस्टैंड द फिगर, कॉलर्स है, तो जब फ्लूइड फ्लो हो रहा है एक्सपैंड होने की कोशिश करेगा, बट दिस कॉलर्स दे विल नॉट अलाउ, तो यहाँ पे लोड P आएगा सर, यहाँ पे लोड P आएगा, बिकॉज इट ट्राइज टू एक्सपेंड ड्यू टू द टेम्परेचर डिफरेंस, बट द कॉलर्स आर नॉट अलाउइंग इट to expand, so it compresses stress P by area, which area is taking hollow area. So therefore the stress is given by 2.34 is expansion. So therefore now I'll write 2.34 is the expansion, but these collars are preventing. So PL by AE. पूछा क्या है सर? What is he asking? Stress or load? एक बार देखते हैं. स्ट्रेस पूछा है सर, नो नीड ऑफ एनी एरिया. स्ट्रेस पूछा है सर. कैन आई राइट दिस एज P by A as sigma? Yes. 2.34 is equal to P by A is sigma. And what is the length given? And this is in mm. This L should be in mm. देखो सर क्या है? Length is given. I think the length is 3 meter ना? The length is 3 meter. Exactly sir. The length is 3 meter. So 3 को हम 3000 mm लिखेंगे by Young's modulus. So Young's modulus is 200 into 10 power 3. 200 into 10 power 3, because it was given in gigapascal, I converted in megapascal. एक बार देखना, units check करेंगे. This is in mm. This L is also in mm. This is in megapascal. This will also be in megapascal. So what is the value of sigma? So if I calculate sigma, 2.34 into 200, 156 कुछ आ रहा है सर. So sigma is equal to 156 MAPA. 156 MAPA is the right answer. Good question. Good question. बहुत बढ़िया सर. These are all under non-uniform heating. ठीक है. ये करो. इसका कोई फिगर है क्या? Let me check. Yes, figure is given. Don't worry. Don't worry. अच्छा क्वेश्चन है सर. Come on, read the question. Just read the question. I am not wasting your time. Read the question. चलिए. A bronze pipe has the inner radius of 12 and the wall thickness 5. So the inner radius is given as 12 mm and the thickness is 5 mm. So the inner radius is 12, thickness is 5. So the outer radius is 12 plus 5, 17 mm. ठीक है. If the gas flowing through the pipe, through it, change the temperature of pipe uniformly from 70 degree to 20 degree. इधर देखना सर. When the fluid is flowing, here the temperature is 70 degree and here the temperature is 20 degrees. Again, it is non-uniform heating. ठीक है सर. Okay. The pipe was fitted between walls. The actual force exerted, force पूछा है सर, force exerted on the wall is, अच्छा E दिया है, E is 103 gigapascal. E is given as 103 in 10 power 3 megapascal. Alpha. And alpha is equal to 17 into 10 power minus 6. ठीक है सर. और कुछ दिया है सर? और कुछ दिया है? Bronze pipe has inner radius. Okay, inner radius, outer. Okay, दिया. Gas flowing, temperature is changing from 70 to 70 to 20 degree. Okay. हाँ. The pipe was fitted between the walls. The actual force exerted on the wall. ठीक है. Very good. क्या करेंगे सर? देखो एक बार. Here the temperature is 70. And one more thing, it is given in the problem, the initial temperature is given. एक second. The initial temperature is also given as 20 degrees centigrade. Let me check. Let me check, sir. What is the initial temperature given? यस, यहां पे एक और एक है, इनिशियली द पाइप, ये सेंटेंस मिस हुआ, वॉज एट 20 डिग्री सेंटीग्रेड। देखो सर, सवाल देखो, नाउ आई टेल यू वेरी क्लियरली। देखो सर, here the temperature is 70, here the temperature is 20. Can I construct, look at, uniformly it is varying, but ये तो non uniform heating है sir. Why is the temperature difference throughout the length of the bar same? No, 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 no. मतलब linearly it is varying, that is the meaning here. ठीक है, तो can I, in the previous question, in earlier two questions, the temperature difference was given directly in terms of x. Let us take this as x, and the length is given as 3 meter. Let me construct the equation first for temperature profile. उसके बाद delta T, because initially it was at 20 degree centigrade, तो minus कर देना, you will get delta T. Initially the complete system was at 20 degree centigrade. Initially the complete system was at 20 degree centigrade. Okay, now let us find out temperature at any distance x from the left end. तो यहां पे हम टेम्परेचर कैलकुलेट करेंगे। सो जो भी वॉल का टेम्परेचर है, इस पाइप वॉल का टेम्परेचर लेट्स कैलकुलेट। तो कैसे होगा सर? इट इज अ लीनियर प्रोफाइल, तो टेम्परेचर एट एनी डिस्टेंस, लेट मी राइट इट एज ए एक्स प्लस बी। कैन आई फाइंड आउट कॉन्स्टेंट्स? यस सर, लेट अस टेक एक्स इन मीटर। तो व्हेन एक्स इज जीरो, व्हाट इज द टेम्परेचर? जब x का वैल्यू जीरो है, जब x का वैल्यू जीरो है, व्हाट इज द टेम्परेचर? 70। जब व्हेन x वैल्यू इज जीरो, हियर लेफ्ट हैंड 70, द बाउंड्री कंडीशन इज at x is equal to 0, the temperature is 70 डिग्री सेंटीग्रेड। दोबारा बता रहा हूं, जब x का वैल्यू 0 है, मतलब यहां पे when x is, this is the temperature at any distance x. Why are you writing linear? Because temperature and this x, it is a linear behavior, he has clearly given. Previously it was a cubic profile. So when x is 0, मतलब left side, the temperature is 70. So t is 70, x is 0, मतलब a into 0 is 0 plus b, it is 0 plus b, so b value is 70. What is the other boundary condition? When x is 3 meter, L का मतलब 3, when x is 3, the temperature is 20. So when x is 3 at the right end, the temperature is 20. When x is 3 meter right hand, temperature is 20. This temperature is 20. Put karo. So temperature is 20 is equal to a, x is 3 meter plus b is 70. Correct ना sir? इज इट करेक्ट? बिल्कुल करेक्ट है सर। सो ये इधर लाना, तो a इज इक्वल टू 20 माइनस 70 इज माइनस 50/3। करेक्ट। सो नाउ द प्रोफाइल विल बी, देखो एक बार, नाउ द प्रोफाइल विल बी ए एक्स प्लस बी। ए, व्हाट इज ए? माइनस 50x/3, ए एक्स प्लस बी, बी इज ऑलरेडी नोन टू मी 70। ये टेम्परेचर प्रोफाइल है, लेकिन आपको डेल्टा टी चाहिए। दिस इज द टेम्परेचर, सो व्हाट विल बी डेल्टा टी सर? डेल्टा टी विल बी इक्वल टू दिस माइनस इनिशियल टेम्परेचर। सो देयरफॉर 70, ये 70 है, माइनस 50x/3 minus initial temperature is delta T. So initially it is at some temperature, you are heating, that is delta T. What is the initial temperature? The initial temperature is given as 20, that is delta T. So ये होगा delta T. 70 minus 20 is 50. So delta T is 70 minus 20. 70 minus 20 is 50 minus 50x/3. ठीक है सर। In earlier two questions, this value was given, some delta T be x cube by. Now we have constructed that equation. Up now the problem is similar, routine problem. देखो, delta T is 50 minus 50x/3. Let me check again. 50 minus 50x/3. ठीक है सर। पूछा क्या है सर? What is he asking? The force exerted पूछा है सर। बहुत बढ़िया, force exerted मैं करता हूं सर। Let us calculate the expansion. What is the expansion? L alpha delta T if it is uniform temperature difference throughout the length. But x I have taken in meter. Please note down that x meter लिए। तो क्या होगा सर? L के प्लेस में dx into alpha into delta T. What is delta T? 50 minus 50x/3. But this will give me expansion in a small length dx. total integrate from 0 to 3 meter. So therefore, alpha is constant. Alpha ko bahar lo. Now, 50 dx is 50x minus 50 by 3 x dx is x square by 2. इसको इंटीग्रेट करें सर. अरे नमूने 0 to 3 50 minus 50x by 3 into dx. Alpha is constant. I have taken out alpha constant. I have taken out this into dx. 50 dx is 50x. 50 by 3 x dx is x square by 2. Limits are 0 to 3. So alpha is given, I think. So alpha कितना आ रहा है सर? Alpha is 17 into 10 power minus 6. 17 into 10 power minus 6 into 50. This is 3 meter. by ये तो 25 से जाएगा. So 25 by 3 square. But you will get this in meter because x is taken in meter. This is the free expansion. Total free expansion. Let me calculate, sir. कितना आ रहा है सर? 25 into 9 by 3 minus 150. कितना आ रहा है सर? एक बार मैं चेक कर लेता हूं रे. 1.275 mm is correct. So it will be 1.275 into 10 power minus 3 meter, or 1.275 mm is the right answer. Correct. Correct. Yes. But he is not asking this. What is he asking? He is asking the load. तो क्या करेंगे? तो 1.275 is equal to, देखो एक बार, see the figure. Now that should be equal to, it is a hollow section, sir. That should be equal to, is it expanding, sir? No, due to the temperature. No. So this is compressing. So which area? On the hollow section. This area. इस area पे compress कर रहा है sir. इस area पे. ठीक है sir. So let me write. So this will be equal to PL by AE. 1.275. As this is in mm, this should also be in mm. P length is 3000. 3 मीटर है तो एरिया. पाई देखो एरिया क्या है सर यहां पे. बी केयरफुल सर. लेट मी कैलकुलेट द एरिया. द आउट पाई आर स्क्वायर और पाई आर ओ स्क्वायर माइनस आर एस स्क्वायर. पाई बाई 4 डी ओ स्क्वायर माइनस डी एस स्क्वायर और पाई आर ओ स्क्वायर. आर ओ इज 17, आर आई इज 12. 17 and 12. 17 and 12. 17 and 12. 17 and 12. Okay. PL by area into Young's modulus AE. PL by AE. 103 into 10 power 3. 103 into 10 power 3. Let us check the unit. Already this is in mm. So this is in mm. 3 meter mm. mm tally हो गया. P is in Newton. This is Newton per mm square. Megapascal. This is mm square. Mm square is gone. Newton, yes, mm. Tell it. So यहाँ से you'll get the value of P. How much is that value of P, sir? एक बार देखो रे, एक बार देखो. 91940 Newton or 19.94 kilo Newton. Let me check. Yes, very good question, sir. चलो कितने क्वेश्चंस हो गए सर? 7. Now we'll have 2 more questions. We'll complete this. ये करो. Read the question. The bar has a cross-sectional area A, length L, modulus of elasticity E, and the coefficient of thermal expansion alpha. The temperature of the bar changes uniformly along its length from TA to TB. यहाँ पे the temperature is TA and the temperature here is TB. Okay. So that at any point the temperature is given as this one. Okay. At any point the temperature is given by TA plus, at any point the temperature is given by TA plus TB minus TA by Lx. ठीक है. TB minus TA by Lx. there is no axial force initially. देखो initially there is no axial force in the bar and has a temperature of TA. Initially the system is at TA. The force exerted on the wall is simple question sir. देखो ये भी इतना प्यारा सा क्वेश्चन है सर. I want delta T. What will be delta T? It will be whatever the temperature is there minus initial temperature. But the initial temperature, देखो, delta T is equal to T. It is TA plus TB minus TA by L into X. This is the temperature minus, always we should calculate delta T. Initially it is at TI, but TI is given as TA. Initially the initial temperature is TA. The initial temperature is TA. So TA is gone. So delta T is equal to TB minus TA into X by L. That's it. तो अभी क्या करना है सर? Logic is same. L alpha delta T is the free expansion. In place of alpha को alpha रखेंगे. Delta T. What is delta T? TB minus TA by L into X. Alpha delta T is this into L. L is dx. Why dx sir? Because it is varying with x. So I will take small x. So therefore in that the expansion will be almost uniform. So therefore ये expansion होगा. Total को क्या करेंगे? 0 to L. This is the total expansion. Same logic. तो alpha TB minus TA by L. Alpha L. What is x dx? X square by 2. X square by 2 का मतलब lower limit has no meaning. तो L square by 2 देखो x dx is x square by 2 तो L square by 2 खत्म, बाय बाय टाटा गुड बाय गया. तो the total expansion will be alpha by 2 into TB minus TA and that should be equal to the total expansion whatever you are getting. And देखो एक बार that total expansion should be equal to compression. What is that compression? PL by AE. That is this should be equal to PL by AE. पूछा क्या है सर? This total expansion, because it is a rigid support. As it is a rigid support, the total expansion should be compression. And what is he asking? Force पूछा है सर. तो he is asking P. तो P पूछा है सर. क्या होगा? यहाँ पे मिस्टेक की है ना रे. अल्फा डेल्टा वी में डेल्टा रे. L by 2. There is L. Alpha डेल्टा टी वी माइनस ओके L by 2. ठीक है. तो ये L कट गया. तो P will be equal to, अगर आपको P चाहिए, alpha AE into TB minus TA by 2. Alpha AE into TB minus TA by 2. ऑप्शन है क्या सर? Alpha AE. Yes, option A is correct. Alpha AE TB minus TA is correct. Correct. The last question for today. ये लीजिए सर जी. The last question for today. Please read this. कुछ फिगर दिया क्या सर? Oh my God! Read this question. देखो कितने short time में I have covered so many quality questions. Just in 1.5 hours, 9 quality questions. Imagine करो sir. How much time I have saved. चलो करो. Read this question. Come on. चलो. When a temperature is at 30 degrees centigrade, the steel pipe fits snugly between two fuel tanks. There are two fuel tanks. एक pipe is fitted between two tanks. इधर देखो. एक pipe है sir. This is the pipe. This is one tank. This is another tank. A pipe fits tightly. Snugly का मतलब tightly between two tanks. When the fuel flows, टैंक में से फ्यूल जब फ्लो हो रहा है, the temperature at the end A and B rise to, here the temperature is 130 and here the temperature is 80. The temperature rises. Initially, ध्यान से सुनो सर, initially everywhere the temperature was 30, but when the fuel is flowing, this side, because fuel may be at high temperature, so when it starts flowing, it is at high temperature, so 130, and when it flows, heat transfer होते जाएगा, तो यहाँ पे थोड़ा कम है 80 degree, but initially it was at 30. Okay, the temperatures at the rise. Okay, if the temperature drop is linear, how the temperature is changing? देखो, here it is 130, here it is 80, and it is varying linearly. So this is length L. So temperature is varying linearly. ठीक है sir. The normal stress developed in the pipe. Assume the walls of each tank. अच्छा, walls of each tank act as a spring. मतलब ये स्प्रिंग की तरह एक्ट कर रहे हैं, ये वॉल, इसके वॉल्स, ठीक है सर जी. ओके, एक्ट स्प्रिंग एंड हैविंग ए स्टिफनेस ऑफ 900 मेगा न्यूटन पर मीटर. इंग्स मॉडुलस इज गिवन, अल्फा इज गिवन. पूछा क्या है सर? द स्ट्रेस डेवलप्ड इन द मटेरियल. मस्त क्वेश्चन है सर, पढ़ो एक बार, जबरदस्त क्वेश्चन है सर. दिस इज 130. The first step is write the equation of temperature, then find delta T. कैसे? Let me write. As it is linear, the temperature let it be equal to AX plus B. When X is equal to 0, this is the one. X, जब X 0 है, देखो ये एक्चुअली टैंक के वॉल्स है, दे आर एक्टिंग लाइक स्प्रिंग. टैंक का वॉल है एक्टिंग लाइक स्प्रिंग, टैंक में से फ्यूल जा रहा है, so therefore they are acting like spring. Directly equivalent figure is given. दो स्प्रिंग्स है सर. चलो, when X is 0, what is the temperature sir? When X is 0, what is the temperature? It is 130. Second boundary condition. When X is L, length दे रखा है सर, कुछ लेंथ दे रखा है 6 मीटर आई थिंक. एक सेकंड देखता हूं सर. यस, दिस लेंथ इज गिवन एज 6 मीटर. ठीक है. When X is 6, temperature is 80 डिग्री सेंटीग्रेड. ध्यान से सुनो सर. Why are you taking linear? वो ऑलरेडी बोला है linear. Let me construct the equation. So when X is 0, तो ये तो 0 हो जाएगा. जब X 0 है, ये 0 हो जाएगा. Temperature is 130, तो B will be equal to 130. Let me repeat, sirs. When X is 0, temperature is B, but T is already 130, B is 130. Next, when T is 80. When X is 6, I repeat, T is 80. This is 6 plus B is 130. तो कितना आ रहा है सर ये? I think it is 50 ना. 80 minus 130 is minus 50. So A will be minus 50 by 6. A will be. So if you write the temperature, it will be AX plus B. A is minus 50x by 6 plus B is 130. ये हमारा टेम्परेचर होगा. सो बट ऑलरेडी ही सेड द इनिशियल टेम्परेचर ही हैज गिवन समथिंग 30. तो इनिशियल टेम्परेचर इज 30. देखो एक बार, इनिशियल टेम्परेचर इज 30. तो व्हाट विल बी डेल्टा टी? डेल्टा टी विल बी इक्वल टू टी माइनस टी है, इसमें से 30 निकालना. सो 130 माइनस 30 इट विल बी 100. लेट मी रिपीट, दिस इज टी माइनस 30 डेल्टा टी. सो 130 माइनस 30 इज 100. तो 100 माइनस 50x by 6. ये हो गया सर. अब नेक्स्ट स्टेप, एज इट इज, वंस द टेम्परेचर इज नो, सॉरी, ऑलवेज इट इज डेल्टा टी. कितना आ रहा है सर? 100 माइनस 50x by 6, इफ आई एम नॉट रॉन्ग. एक बार चेक करता हूं. 100 माइनस 50x by 6. 100 माइनस 50x by 6. ओके, अब देखो, लेट अस कैलकुलेट फ्री एक्सपेंशन. कितना होगा? देखो, इंटीग्रल 0 टू L क्या है? ऑलरेडी इतने क्वेश्चंस किए सर, अभी पूछ रहा है L अल्फा डेल्टा टी फ्री एक्सपेंशन. अल्फा एक डेल्टा टी. व्हाट इज डेल्टा टी? 100 माइनस 50x बाई 6 डेल्टा टी. L अल्फा डेल्टा टी. L के प्लेस में क्या है? dx. स्मॉल लेंथ पे आई एम कैलकुलेटिंग द एक्सपेंशन. सो टोटल विल बी इंटीग्रेशन ऑफ दिस. सो फ्री, सेम क्वेश्चन सर, हजारों क्वेश्चंस किए ऐसे. सो फ्री एक्सपेंशन विल बी इक्वल टू, तो अल्फा इज गिवन आई थिंक, इफ आई एम नॉट रॉन्ग, बट दिस विल बी इन मीटर सर, क्योंकि ये मीटर में दिया, तो आंसर विल बी इन मीटर. तो अल्फा इज गिवन एज 12 into 10 power minus 6. अल्फा इज 12 into 10 power minus 6. Okay, 100 dx is x, 100x minus 50x square by 2. तो 1 by 6 एज इट इज रहेगा. 50x square by 2, ये 2 ones 225, 25x square should be correct. एक बार देखना, 50 by 6, तो x dx is x square by 2, 2 ones to 25. 25 x square by 6. Correct. So it is 0 to 3. Excellent, sir. So free expansion is equal to 12 into 10 raised to minus 6. ठीक है सर जी. 100 into 3 minus 100 into 3 minus 25 by 6 into 3 square, that is 9. तो ये आ रहा है आपका బావా నేను మళ్ళా చేస్తా బావా జర్ర క్లాస్లో నా నేను చేస్తా బావా ఓకే 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 ठीक है now 25 into 9 by 6 गलत किया क्या मैं कुछ तो गलत किया क्या सॉरी आई मेड अ मिस्टेक द लेंथ इज 6 तो यहां पे 3 कैसा आएगा रे लेंथ इज 6 आएगा यहां पे दिस इज 6 नॉट 3 प्रीवियस क्वेश्चन का 3 था यही तो मिस्टेक किए रे बाबा यही तो मिस्टेक किए थे अब कैलकुलेट करेंगे आई एम रियली सॉरी फॉर दैट 150 कितना आ रहा है सर 450 into 12 you are getting this as 5.4 into 10 power minus 3 मीटर और 5.4 ये होगा आपका लेंथ बहुत बढ़िया बहुत बढ़िया मेरा याद प्रीवियस का गया प्रीवियसली इट वाज 3 मीटर ना सो दिस क्वेश्चन इज 6 मीटर करेक्ट 6 मीटर है सर सॉरी इट्स नॉट 3 इट इज 6 तो 5.4 आ रहा है तो नेक्स्ट क्या करेंगे सर सिंपल है सर 5.4 is the total expansion it is in mm so total expansion should be equal to total compression कैसे देखो एक बार total expansion should be total compression अब क्या क्या compression है बोलो spring compression rod compression and spring compression so when it tries to expand these walls don't allow it to expand so they offer a compressive force R1, R2, but there is no external force. R1, R2 will be same. Let it be equal to P. So compatibility equation क्या होगा सर? Total expansion we have calculated by integration should be equal to total compression because the distance between the rigid walls is not changing. So total expansion should be total compression. What is the compression? Spring compression. Spring compression double होगा प्लस ये वाले का कंप्रेशन ये वाले का कंप्रेशन ये वाले का कंप्रेशन ठीक है सर ये वाले का and the inner radius is 150 and the outer radius is देखो the inner radius is 150 and the outer radius is 150 plus 10 160 let me repeat the inner radius is 150 mm and outer is 150 plus 10 outer is 160 mm बहुत बढ़िया सर बहुत बढ़िया अब देखना सर now I'll write the compatibility equation so two springs are compressed so spring index is forced by deflection so deflection is P by K so therefore first spring ka P by K second is also same both are same in load is also same therefore I am writing 2 plus PL by AE there is actual load in this khatam sirs khatam so total expansion should be equal to total compression total expansion should be equal to total compression because compression on ek bar main batata hu compression of this the load is P so PL by AE P by K is the compression of these two springs twice and ये हो गया and what is asked in the question एक बार देखो नॉर्मल स्ट्रेस पूछा है सर नॉर्मल स्ट्रेस पूछा है चलो हम लोड कैलकुलेट करेंगे उसके बाद स्ट्रेस कैलकुलेट करेंगे या फिर ऐसे कर सकते हैं बहुत सिंपल है सर कोई बात नहीं सर लेट्स कैलकुलेट दिस 5.4 is equal to twice what is P I don't know K the stiffness is given sirs What is the value of K sir? Stiffness दिया सर देखो एक बार कितना दिया 900 मेगा न्यूटन पर मीटर कुछ दिया है सर द स्टिफनेस ऑफ द स्प्रिंग वेयर इज दैट कहां गया रे वो 900 मेगा न्यूटन पर मीटर इसको हम मिलीमीटर में कन्वर्ट करेंगे 900 mega is 10 power 6 newton mega is 10 power 6 meter is 1000 mm तो ये 10 cube कट गया so therefore it will be 900 into 10 power 3 newton per mm because देखो 2 P लोड को न्यूटन में ले लो, K इज लोड को न्यूटन में ले, ये न्यूटन पर mm, न्यूटन कौन mm, ऑलरेडी दिस इज इन mm, टैली इट. So K is how much, sir? 900 into 10 power 3. Why have you taken this twice? Because दो springs है, दोनों का compression. Plus P, what is the length? 6 I think. तो इसको 6000 लिखना, because we it should be in mm. Area देखो सर, एक बार एरिया देखो. What is the area? What is the area? Pi RO is 160, RI is 150. RO is 160. 160 minus 150 square. Excellent. By PL by A E. What is the Young's modulus, sir? What is the Young's modulus, sir? E दिया है. What is the Young's modulus? Somewhere it is given. 200 gigapascal. 200 gigapascal. So it will be 210 power 3 megapascal. I have converted giga to megapascal. So everything is known except P. Please calculate P. एक बार चेक करता हूं. So if you are calculating 101844, 1018, let me check, 1018441, 441 Newton. But he is asking stress. What will be the stress by area? So stress will be equal to 10184441 by area is pi into RO square 160 square minus 150 square. Let me calculate the stress. एक बार चेक कर लेता हूं सर. 1018,441 divided by pi divided by this, तो ये आ रहा है 104.5 megapascal. And please, such questions can be asked. I'm not saying क्योंकि इसरो एग्जाम आ रहा है, ये मत बोलो कि इसरो में ऐसे टफ क्वेश्चंस आएंगे. नो सर, लेकिन इतने लेंदी नहीं आएंगे. आई नो दैट, बट कॉन्सेप्ट्स रिलेटेड टू दिस विल कम. सो वॉट एवर क्वेश्चंस आई हैव कवर्ड फ्रॉम वेरियस एग्जामिनेशंस पॉइंट ऑफ व्यू. एंड यू शुड अप्रिशिएट वन थिंग कि इन अ स्मॉल टाइम, आई थिंक इन अबाउट 1.5 hours or so, I covered 9 quality questions. These are all conventional questions and concepts open up हो गए सर. So kindly do not forget to leave the comment. अगर आपको ये अच्छा लग रहा है तो कमेंट लीव करना. ओके, ऑल द बेस्ट. थैंक यू. आई विल कम अप विथ मेनी मोर सच वीडियोस. थैंक यू. गुड बाय. बाय बाय.